Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Our phone tutors are here if you need help with your math homework, maybe you're studying for a test, maybe you've got some makeup work you're working on. Give us a call here in Bakersfield at 636-4357. Outlying areas such as San Luis Obispo, there's a toll-free number, 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show online at dothemathonline.net and look for us on social media. We're on Facebook and Instagram and Twitter and YouTube.
And whatever else comes out next, I'm sure we'll be on that also. Anyway, a couple of things to take care of before we get to our couple of special guests this afternoon. Our first phone call. Congratulations once again to the 5th grade class at Noble Elementary. Mr. Knox's 5th grade class was the winning class last month for the classroom that phoned in the most for the 5th graders. So congratulations once again to that classroom. Also, if you are calling from San Luis Obispo County and we do your math problem on air, you will automatically win yourself ice cream, courtesy of our friends over at Doc Bernstein's Ice Cream Lab. And speaking of winning, every single student that phones in today will automatically win a ticket to the final day of the March Meet drag racing at Famoso Raceway.
That's cool.
So you don't have to wait to win. You will instantly win if we do your problem on air, as well as your name then goes into a bucket for condors. So somebody could be a double winner here today.
There you go.
Anyway, before we get to our guest and our first phone call of the afternoon, let's first take a look at today's Math in the News. Well, very current math in the news. The drag races are going on this week. And one of the guys that works here, John, I think the highest up person here, is actually at the March Meets working with his team and his dragster and things like that. Dad, you know John races?
No.
Yeah.
Didn't know that.
We'll grill him next week when he gets in here a little bit about this. But this is one type of dragster.
Yes.
All right. You know how there are these fantasy things where you can pay and you can be like a member of a baseball team during spring training for an inning, and there's some way you can get in a race car with a professional race driver and, you know, take a lap or a couple laps or things like that. Would you do a drag race?
Yeah, I think I would. That'd probably be pretty exciting. Probably never been that fast yet.
Right.
Acceleration.
Well, wait until we find out a little bit more about this. All right. So this is a burnout. All right. So the burnout is when the rear tires are spinning in water to heat and clean them before a run for better traction. In most classes, a burnout precedes every run down the drag strip.
Wow.
So before you take off, you need to do a burnout, which I thought was just, looks cool. But there's actually something behind it. All right. Do you know what this is? There's I know it's lights, but there's a name for it.
The Christmas tree.
The Christmas tree, exactly. So the noticeable electronic starting device between the lanes on the starting line, it displays a calibrated light countdown for every driver. The time it takes a driver to react to the green starting light on the tree, measured in thousandths of a second.
Wow.
A perfect reaction time is 0.000, because that would be perfect.
Perfect.
Otherwise, you would have a 1, And
Yeah.
that's fast, but perfect.
Wonder what's the closest someone's got to being perfect. That's got to be pretty tough.
Right. And I mean, because you would have to hit that thing as it was turning
Right.
that color. You know, it's like as it hits green, you've got to be on that thing. Because if you're a thousandth off,
If you're too soon, it goes
You're
down
gonna
to
be
red.
disqualified.
And it goes down to red, right?
Right.
Yeah.
so
There you go.
you still want to go drag racing?
Yeah,
Okay.
no, I think the funny cars, not those.
Okay, so this is a top fuel dragster, the fastest accelerating vehicles in the world. The 25-foot long landlocked missiles, that's what they're called, can cover a quarter mile, which is what the track is out of Famoso, quarter mile in 4.4 seconds at speeds faster than 335 miles per hour.
That's crazy.
Okay, so you were saying you never have an opportunity to go that fast. I mean, if you're in your car, you're driving along, let's say there's times when you go 70, 80 miles an hour for whatever reason, multiply that by 4.
I know.
Okay, you're going 330 miles an hour. The nitromethane powered engines that the dragsters produce are approximately 7,000 horsepower, 37 times that of the average car. A top fuel dragster leaves the starting line with a force nearly 5 times that of gravity. The same force the shuttle has when it leaves Cape Canaveral off the launching pad. In just 660 feet, they're already up to 300 miles an hour. They weigh close to 2,500 pounds.
Really?
All right.
Wow.
So those are just some of the facts about that. And so I figured, all right, let's take a look at a streetcar. Okay. So there are formulas that they use, and one set of formulas for predicting miles per hour and elapsed time, which is the ET. So these are the formulas where H is the horsepower, W is the weight in pounds, including the weight of the driver. The units are elapsed time. So you could be doing, as an example, streetcar weighs 2,830 pounds. Driver included, horsepower of 220. Drag race is a quarter mile track, just like they have out there. The predicted speed would be you would get to 98 miles an hour, and it would take you about 15 seconds.
Right.
So if you brought your car out,
Right.
then it was fine working condition.
Not my car, but your car in pretty good condition.
Right. And so you could go on the quarter mile, and instead of getting down there in 4 seconds, it would take you about 15 seconds.
Right.
Because
about
you're
right.
going about 98 miles an hour would be the top speed you would be able to get on that track.
Right.
And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays. Need to bring this up because in a couple of weeks we'll be off live shows.
Yes.
So I think once the time changes, and I believe it is right before spring. I think spring is on the 20th this month. So
Yeah.
the couple of days right before that, it must be the 15th and 16th, I think.
think that's
so
last
those
days.
will be the final 2 days for live programming for this year. But all students that phone in today will be receiving a free ticket to the March Meets final day out at Famoso Raceway to see the dragsters, and I would say probably bring earplugs as well. Anyway, we'll go to the phones right now, and from Valley Oaks, Gabe, how are you today?
Good.
And what grade are you in?
4th.
All right. Gabe, as soon as you're ready, let's hear the math problem that you're working on.
All right. Well, I'm working on 2. The first one is 8 times 6 tenths.
8 times 6 tenths,
Yeah, 6 over 10.
and the whole number 8 times 6 tenths. Okay? So we're multiplying a whole number times a fraction, and you know when you do this, you really want to multiply a fraction times a fraction, don't you? So how do you make the whole number 8 into a fraction? Do you know how to do that?
Maybe like 8 out of 8 tenths.
Well, let's see.
8
If I put
over 8?
if I put 8 on top, what do I have to divide by to make that 8? 8 over 1. So
8.
any whole number can be written as that number over 1, and that makes it into a fraction. Improper fraction, but it's still a fraction, isn't it? All right, now let me ask you, when you do these problems, does your class multiply across first and then reduce, or do you reduce in the problem?
I'm not really, well, the question is, I'm not really sure. I guess we can do the top, then the bottom.
Yeah, so one way you can do this problem is we can multiply the top, 8 times 6, right? So what's 8 times 6?
8 times 6 is 44, I think it is.
Close. 6 times
48.
8, that's going to be 48, isn't it?
Yeah, 48.
And the
Oh,
bottom's easy, 1 times 10, that's just 10, isn't it?
Yeah.
So we have an improper fraction. We have 48 over 10. So
Yeah.
now we got to change that to a mixed number, don't we?
Yeah, I think so. Yeah.
So let's just keep doing the problem. We know that 48 over 10, 48 tenths, means 48 divided by 10, doesn't it?
Yeah.
So I'm going to take 48, and my divisor of 10 goes out in front. And how many times does 10 go into 48?
4 times.
4 times. That's 40, and so we have a remainder down here of 8, don't we?
Yeah.
So we know that our whole number is going to be 4, and our fraction is going to be, well, our bottom number was 10. That's going to stay 10, isn't it?
Yeah.
And our remainder is 8.
Yeah.
So we know this is going to be 4 and 8 tenths.
Okay.
All right, now we haven't done any reducing as we've gone along, but now can we reduce? We've changed it to a mixed number with a whole number and a fraction, but can you reduce 8 tenths?
Yeah.
Yeah, because what goes into both 8 and 10?
8 and 10.
Yeah, what?
2.
Yeah, I can divide both of them by 2, can't I? And I get 8 divided by 2 and 10 divided by 2. And so my final answer is going to be the whole number 4. That was our quotient. And the fraction is going to be 4/5. And that should be the answer to that question. Okay?
Yep.
All right.
And
Thanks
I
for the
think,
call.
Gabe, you said you had a second problem that you were working on?
Yeah.
All right, we do have time for it, so let's go ahead and hear that one.
Okay, so let me start over here. Okay, why don't you give me the next one?
The next question is 7 over 8/12.
7 over 8/12?
It's probably
No,
7 and
sorry.
8/12.
Oh,
7
seven-
times 8/12.
Okay, the whole number 7 times 8/12.
Yeah.
All right? So now we're going to approach this problem the same way, aren't we? Let's change 7 to a fraction. What's it going to be? 7 over
1.
1, right? That doesn't change, right? 7 divided by 1 is 7, isn't it?
Yes.
Times 8/12. All right?
Yeah. I guess.
So let's do the multiplication. 7 times 8 now.
Oh. I think I'm not really sure. I'll just.
Well, we know that 6 times 8 was 48, right?
Yeah.
Now we have 7 times 8, so we're going to take one more 8, aren't we?
Yeah.
So
that'd
one
be
more 8 is going to be
52.
56.
Yeah.
So 7 times 8 is 56, and again, the bottom number is just 1 times 12 is 12. All right?
Yeah.
Now what do we do with that improper fraction? Divide, right?
Yeah.
I'm going to take 56, and my divisor is 12. How many times does 12 go into 56?
12 going to 56. Like, I think 5 times?
5 times. Let's see. What's 12 times 5? Let's see. That's a good guess. Let's see how close we came. 5 times 2, that's 10. And 5 times 1, that's 5 plus 1. Well, that gave us 60, didn't it? A little
Yeah.
bit too big. So instead of 5, since we were pretty close, what should we try?
4.
4. Let's try 4. 4 times 12 is
4 times 12
48.
is
Right?
48.
48. And when we subtract, let's see, what's 56 minus 48?
56 minus 48 is, I think it's like 20.
Well, let's see, 56 minus 48. So if I borrow, 16 minus 8 is 8, isn't it?
Okay.
So I know it had to be less than 12. So I'm going to get a fraction here. My denominator is 12, And my numerator is my remainder, so that's going to be 4. There's our whole number, right?
Yeah.
And 8/12. Now, can you reduce 8/12?
8/12. Yeah.
What do you
I
get?
think so.
Divide by,
I think you can divide it by 4.
yeah, so in this case, now I can use, instead of just 2, I could use 4. So what do we get? 8 divided by 4,
8 divided by 4 is 2, and
12 divided by 4.
is 3.
So it looks like our answer is 4 2/3. That mixed number looks like that's going to be our answer. Okay? Great problem. Thank you.
Nicely done, and congratulations also, Gabe. You've got yourself a ticket to the final day at the drag races at Famoso Raceway. In studio with us, John Nyland. How are you?
Very well, and how are you today?
Excellent.
Super.
Have you been to the drag races ever?
I have. I actually worked on a pit crew one time.
Oh, you did?
Yeah, absolutely. And one of the math issues that they take is tire pressure, how important that is, making sure it's the right pressure for the temperature and the ambient air around it. So very critical for those cars to go fast to make sure their tire pressure is exactly right for the
Exactly, because we had one of the managers, Mackay from America's Tire, on a couple of weeks ago, and we were talking about tires and the size of them. Make sure you have the right size for your car, the pressure, and then how they can determine miles per hour and things like that. So how long were you on the pit? Was it just a one-time thing?
I did that for a couple years when I was much younger. It was
Okay.
a lot of fun. And we also did Mesa Marin when it was out
All
at
right,
the
yeah, when
racetrack.
I was out there?
Yeah, a lot of fun.
All right, well, you know what? You're here not to talk about the racing and things like that, but you work for the County of Kern.
I do indeed.
And what is your title?
I am the County Administrative Officer, and that is the highest non-elected position in the county.
I was going to say, there's nobody above you,
Well, the Board of Supervisors, the
Okay.
elected officials, they're the ones who are above me.
so they keep an eye on you. But as
Yes,
far as
or I keep an eye on them,
non-elected-
I'm
right,
not
I was going to
sure.
say. And do you have to attend many of those meetings, or all of those meetings, or none of those meetings?
Every meeting.
So every
single
meeting you're at.
Every Tuesday.
And they can get quite lengthy.
They can get lengthy, they can get complex, they can even get contentious. And
Okay, well, yeah, well, we'll leave that to another show. We're just going to talk about the math things right
Okay.
now. Anyway, so in your position, and how long have you been with the county?
I've been with the county 31 years,
And how long in the position that you're in now?
about 7.
Okay. And we got you at the right time, because when we called yesterday to confirm, we found out yesterday you are retiring soon.
Right, I announced my retirement, and I will retire in the first week of January.
Well, congratulations on
Thank you
that.
so much. I very much appreciate that.
As far as your position right now, how do you apply math in what you do? Maybe not every single day, but these are the things you're good with, and you need to be able to kind of do them right away.
Well, one of the things we do in my office is we create the county's budget, and our county's budget is $2.9 billion. So that requires a lot of adding and good with lots of zeros. And we also have to divide up the budget by the different departments, and we have to incorporate certain parts of a budget, salaries, benefits, what things are purchased, how they're purchased, how long the buying cycle is, and we have to establish a budget. And then we have to make sure that everybody's spending the right time for the right amounts to make sure that we're balanced and that we're not in trouble with anybody at the state or federal government.
Okay, because you might say, for example, this sector, whatever, we're going to give you $1 million.
Right.
You've got $1 million to use, but you can only use a certain amount during certain times.
Right. Well, and what we're most interested in is you get $1 million and you can use any part of it during the year. But we have to make sure you don't use more than that. So
Okay.
every quarter or every period of time we look at it and we do some ratios to say, okay, you've spent 40% during the first 25% of the year. Oh my goodness,
Okay.
that could be a problem.
Gotcha.
And so we have to always keep an eye on it using that kind of math.
And before you were in this position where you had to deal with budgets all the
Right.
time, what were some other responsibilities and duties that you had
Well,
with the county?
the great thing about the county is there's so many different things that you can do. I was the public health director, I was the child support director, the employers training resource director. I was involved with our workforce development, our personnel department, our environmental health department. Many, many different things to do in the county, and I always encourage people to consider that as a career.
If there's a student right now watching and they're in maybe junior high and possibly high school,
Right.
are there things that they should be kind of aiming towards, and possibly things outside of school they could do if they want to possibly follow this path?
Sure, and there are a lot of things that if people want to do. If they like nursing, we have a hospital, a public health department, and a mental health department. So we can work with different schools and help get some interns or some time with the different programs. That's exciting. If people like architecture or engineering. We have many architects and many engineers. If they like administration, they like just to add numbers, we've got accountants, we've got all sorts of things. And they're always welcome to meet with our department heads and our staff. And then sometimes we're able to set up internships and get classes involved.
Perfect, exactly. So if somebody wanted to work for the county, simply go online.
Right, go online, and we have a number of departments. My department is the county administrative office. Email me, my email address is there, and we can see what we can do to set some students up or some classes up or schools up with our programs.
You've been in your position, you said, for the last 7 years.
Right,
You're at 2.9 billion.
right.
What was it, do you remember when you first started?
I think it was just around 2 billion, so we've grown pretty sizably over the last 7 years or so. Some of that has to do with new programs that the state and federal government say you need to do, and so it just grows and it grows in those areas. One of the things is that we do a lot of work with our sheriff's department, and our sheriff's department grows and our fire department grow because our population is growing.
Yeah, well, since I moved here from New York, the population has grown significantly since I've been here.
Absolutely.
And you know what? We certainly do appreciate you taking some time.
Anytime.
Have you got just one more moment?
Sure.
All right, we're going to have Chuck work on a problem, and then we're going to chat with you just one more moment quickly.
My pleasure.
All right. Chuck, we've got a survey.
Okay.
All right. 14 middle school students. The mean number of minutes that they talk on their cell phones in a week. So
Number of minutes.
they
Okay.
talk on a cell phone a week. So before I tell you what it is in the problem, John, a middle school student, 7th, 8th grader, probably 13 years old.
Gotcha.
How many minutes do you think they talk on the phone a week?
Too many. But I would probably suggest a week on the phone. I would say probably 25 hours.
That's a lot of time.
I
They're
have
probably on it 25 hours.
Okay, maybe not talking. There you go.
Right, yeah. So we're going to do the talking part.
Okay.
So this is going to be 133 minutes a week.
Okay.
It's funny you bring that up because there are a lot of times you'll see students, and as far as down as elementary school, and especially middle and junior high and high school, just constantly. I mean, there's going to have something happen to our thumbs soon. I think.
I have
Evolution, yes.
Yeah.
I have a
You know, we're-
14-year-old, and I think,
Okay, so
I think
you're
it's
right on
glued
this.
to his hands.
Okay. So what we need to know is the total number of minutes the students talked in a week, and then we'll go to the second part.
Okay. So we know that the mean number of minutes, the mean is not how many each student actually talked on the phone, but it's the average for all of those students. So some of those students probably talked more than that, some of them talked less than that, but over the course of the week, the average per student is going to be 133 minutes. That means we can use that and multiply that times the number of students, and that'll give us our total based on this average. So if I take 14 students, and on average, each one of them talks 133 minutes, all I have to do is multiply that out. Let's do that right here. Not a bad problem to do without a calculator. So I get 12, 13, and 5, and then 3, 3, and 1. And if I do this problem, it looks like 6, 8. It looks like 1,862 minutes would be the total that all of those students, on average, would speak on the phone for the week.
All right, and the second part of that problem is what is the amount that a student talked in a day?
Okay? So if I take all of that, and if that's for the week, I'm going to divide that by 7, and that should give me, so for one student
For
in a
one
day.
student,
So this
right.
is all of the students, right?
Right.
So you want just one student. So the average, let me get this back here. Did I lose that page?
There you go.
So that's for all of the students. So if I take the average for the week, that's the mean number of minutes for the week. If I take that per day, right? So one student, that'd be 133 minutes per week, and I just have to divide that by 7,
Right.
So if I divide that, let's divide that. And let's see, I'm going to get 1, that's 7, subtract, I get 6, 7 goes in 63 9 times, so that looks like an average of 9 minutes per day. How's that? Or, excuse me, 19 minutes per day.
19 minutes. So, John, you think your child speaks about 19 minutes a day on the phone?
At a
actually
minimum,
talking?
he might be at the other end of the average,
Yeah.
but yes, 19 minutes.
Skewing it way up a bit
Yes,
there.
absolutely.
All right. You know what? All right. Nicely done on those two parts of that problem right there. You've got retirement coming up.
I do.
Any plans once that happens?
Well, you know, first of all, the county's been a great place to work, and I've really enjoyed it. So my plans right now are to work with, I'm involved in my college's alumni association statewide, so spent a lot of time working with that, a lot of time at my church, and then this daunting list of honeydews that I'm going to have to do.
I'm sure that will grow and grow and grow.
Yeah.
Well, you know what? I'm certainly glad that we were able to get you on air before you
Absolutely.
actually did go into retirement. If it happened to be that you were retired when we were able to get you on, we would simply talk about what you're doing during retirement. and how
There you
plan
go.
after that.
Absolutely.
Anyway, we have our next special guest coming up right after this.
The wing itself is just an amazing tool, and this is what creates the lift to be able to lift this airplane off the ground. Now at takeoff, this airplane weighs 20,200 pounds, okay? That's how much it weighs at gross weight. And all the performance numbers that have been developed for this airplane are based on weights. So when you talk about numbers, you talk about things, everything we do is based on numbers and performance. So this wing is what creates the lift to be able to pull that 20,000 pounds up. But once we're flying, you got to ask yourself, okay, how do we control the airplane? Well, if we want to go right to left, okay, laterally like this, we control it with what's called the ailerons right here. See these? And you look at the aileron and you watch it go up and you say, okay, what does that do? Well, remember, this air is coming across this wing at 200 or 300 or 400 miles an hour. As soon as it hits this, what's this wing going to do?
It's going to be deflated. So what you've got is you've got the ailerons affecting whether or not it's going up or down.
That's right, this wing. So this is going to do what? It's going to lower this wing, right? Now, if we were going to look at the other aileron, what do you think it's doing? The exact opposite. What's going to happen is this wing's going to lower, the other one's raising the wing, so we're going to make a right turn. We want to make a left turn, then this wing is going to go up, and the other wing's going to go down. So these are the ailerons. Then we have the flaps. And what flaps do is at lower speeds, the wing becomes less effective. Okay? And so what we do is we increase the wing area by bringing these flaps out and down. And for any of the kids that have flown on an airliner,
If they've looked out the side, they've seen that happen.
Look outside the window and watch the flaps on the back of the wing. And those wings are sloped more for higher speeds, but they also have slats, which are called slats in the front to increase lift also. So the front of the wing goes down, the back of the wing comes back, and that's all designed to be able to let the airplane fly at slower speeds. This is the rudder of the airplane right here. You can see how it moves, okay? And that's controlled by the pilot's feet. We control the rudder by the feet inside the cockpit. Now, when we're on the ground, those controls, foot pedals, are controlling nose steering. But as we take off and all of a sudden we accelerate and there's enough airspeed over the rudder, then it transfers, and now this control here, yaw, now is controlled by the rudder.
Got it.
Okay? Now, but the only way we can get off the ground is by putting the airplane nose up, right? And that happens right here with the elevators. And what the elevators do is they both work together and they go up. And when the elevators go up, they push down, which raises the nose, and the airplane climbs like that.
So the elevators control the pitch of the plane,
That's exactly right.
whether you want to go up or down.
And that's a good point. There's three axes of flying. You've got pitch, yaw, and roll. And those three things put together makes every airplane ever built fly. Right now, what we're doing is an inspection right now, so you can actually see the sophistication of the engine. This is the fuel control unit. This is what monitors and changes fuel flow that goes into the engine. A very sophisticated computer tool that analyzes basically the amount of fuel that goes into the engine, because that has to change for altitude for temperature, and for all the other things that are going on while the airplane is flying. This is a Pratt & Whitney 545W. It produces 4,100 pounds of thrust, and at takeoff, this engine's burning right around 200 gallons per hour, and at cruise, it's down to about 90 gallons an hour.
How much fuel can this plane hold?
1,000 gallons.
1,000 gallons.
Right. And has the range to fly almost 2,000 statute miles. As this airplane flies through the air at 400 to 430 knots speed, tremendous amount of static electricity, especially in clouds and in rain and snow.
And just a reminder, we do have phone tutors available until 5:30. 636-4357 is that phone number. After today, only 2 more weeks of live programming for Do the Math this season. In studio with us right now, Alex, how are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
Leo B. Hart School.
So you go to Hart, so you're a Hawk. And what
Yes.
grade are you in this year?
5th grade.
How's 5th grade going?
Good.
What's hard about 5th grade?
Everything.
Everything? Oh my gosh. So it's not getting easier as you go on in school? It's getting
No.
harder?
Yeah.
Well, guess what? You've got a couple more years, so it's going to keep on getting harder and harder. But anyway, if you need help with your math, you know where you can turn, right? All you have to do is give us a call. We'll help you out, right? As long as it's a
Sure.
Tuesday or a Wednesday. So we know that school is getting harder for you, and that's fine. There's nothing wrong with that. What is the best thing about 5th grade so far?
PE.
PE. Is there an activity you like most, or just PE overall?
Well, math is sort of fun.
All right, so you like math also?
Yeah.
All right. Now, you're here. You were a guest on this program before, right?
Yes.
And you're here again as the second time because it's going to be quite difficult for you to be a guest live on the show for a third time. But we might get you on for a third time using Skype next year because you're moving, aren't you?
To Vermont.
You're moving to Vermont.
Other side of the country.
That's it, all the way over to the other side of the country. And you'll be in a whole different time zone. So if you call us, it's going to be a little bit later in the afternoon. Are you familiar with anything about Vermont right now?
Vermont means Green Mountains.
Right, it is the
in
Green Mountain State.
French. It's really hilly, green, has snow and rain, and like us.
Indeed, it does.
And
Do you know the capital of Vermont?
does it start with a C?
With an M,
Then I don't know.
Montpelier.
Okay.
Montpelier is the smallest capital in the United States as far as people living in the capital. There are only 8,000 people living in Montpelier, Vermont. There's probably 8,000 people living around your school out here. And one other thing, and I want to see if you can have an idea about why this might be. And you can also ask Chuck and see if he has some ideas. There's one thing in Vermont that is illegal, and that is billboards. Billboards, you know what billboards are?
Yeah, like those giant signs that give out a product.
Right, so as you're driving along the streets, you see all these big billboards, right, all over the place. Those are illegal in Vermont. Do you have any idea why?
Because it's like so high of an altitude since there's so many mountains.
Kind of. You're on kind of the right
It
track.
rains so much.
Do you have an idea to? Because I know I'm just throwing you guys on the spot here.
My guess is that they're ugly.
Right, they block the natural
You can't see the
beauty.
mountain. You can't see the mountain.
They block the beauty of the hills and mountains in Vermont, so they made it illegal to put billboards up in Vermont. So when you're there, don't look for any billboards. All right? Are you ready to do some math right now?
Sure.
All right, let's get to the board. That's why you're here, is to do some math.
Okay.
So I know that right now you're working on dividing fractions, but first we're going to start with multiplying first. All right, so we're going to multiply some mixed numbers. All right?
Okay. Grab a pen.
So we have, let's say 1 3/4.
Yeah.
I think your hand's a little too close to the board, so just hold the
There you
pen.
go, there you go.
There you go. 1 3/4 times 2 and 1/2. So if you would be so kind as to multiply those out and explain to us what you're doing as you go along.
Well, first I like to multiply the whole numbers because they're the easiest. 1 times 2 is 2.
But you got to remember, when you're doing these problems, you got to incorporate that whole number in
I know.
there. So what do you have to do with that 1 3/4 before you can do any multiplying?
I need to change it so that they're both the same fractions.
Well, we got to make sure that they're both fractions. So if you
Yes.
remember the column we just had, we got to make sure that this is a fraction and that's a fraction. So let's go ahead and do that. What do you do with 1 3/4 to make that a fraction? Let's get rid of this first. What do you got to do with 1 3/4 to make it just an improper fraction?
You can multiply the 4 by the 1 and then add 3,
Right, so
which
let's write
is
that as?
7/4
There you go.
times 2 times 2 is 2 times 2 is 4 plus 1 is 4/2.
But wait, you forgot you added the 1, right?
Oh, right.
There you go.
2 times 2 plus 1 is 5/2.
Okay.
So now if we multiply these, 4 times 2 is 8, and 7 times 5 would be 35. Of
Now,
course,
sometimes that can be your answer. There are some classes where you could leave your answer as an improper fraction, 35/8. But most of the time, what do you have to do with that?
change it into a mixed.
Change to a mixed number. How do you change that into a mixed number?
Okay, so we're going to have to multiply the 8 so that it's close to 35.
Yeah,
So 8 times 4 would be the closest because it's 32. So 8 times 4, 32. 32 and minus 35 would be 3, which is, and I'll put that 3/8. And there you go. We can't simplify it anymore because the 3, it's an odd number and not an even number.
So what operation you just used, you did it in your head, but when you said 8 times what is close to 35, you actually divided 8 into 35, didn't you?
Yeah.
And that's where that 4 came from. All right, and your answer is 4 3/8, and you said 3/8 doesn't reduce, does it? So there's your answer, 4 3/8.
All right, nicely done. Go ahead and erase that board right there. So we've done the multiplying.
Right here. There you go.
Now we'll divide. So we're going to go 6 divided by 1/5.
1/5.
There you go.
Okay, this one is usually strange because 1/5 divided by 6 will never be the same because, well, 1/5 divided by 6, you see, it needs to be a smaller number than 1/5, which means we'll have to make this number bigger, but since it's a 6, we need to make it...
So what are you going to do with that 1/5?
I'm going to switch around the 5th so that the 1's under, and now we have the 6. And we change this dividing sign into a multiplying sign.
Okay.
And now this equals, technically it would equal 30/1, but
Because
we
what
can,
do you do with that whole number 6 to make that a fraction?
well, we can bring a 1 under.
Yeah, so we have a 5/1, and now we have a 6/1.
But we don't need the 1, we can just have 30 as the answer.
Because you know this is a division problem, and 30 divided by 1 is just the whole number 30, and you get that whole number 30. There
All
you
right,
go.
nicely done. Erase that. I've got one more for you.
Right.
Oh, one underneath. There you go. So hit the cancel on that.
No, this one right there. There you go.
All right. So now 1/7 divided by 3.
So now,
Yeah, you got it.
so now we're gonna figure out 1/7 divided by 3.
3.
So now we're gonna learn why they're not the same. Since this is a fraction, we need to make it a fraction. So we'll turn this into a fraction by putting a 1 on the top. And so now we multiply the 1, which is 1. And now we have 7 divided by 3. Well,
So now you change it into multiply.
we have to
So 7
change
times
the
3 is?
divided by 2. And now 3 times 7 is 21. So
Right.
this is the answer, because
So you left the first number alone, you didn't change it, but you changed it to multiplication, and you changed that second number and you flipped it over. Do you know what it's called when you flip that number over?
reciprocation?
Pretty close. It's the reciprocal.
Reciprocal.
Reciprocation is the action you did, but it's reciprocal that you used. Yep, and there's our answer.
There you go. Nicely done. Nice use of the vocabulary as well
Yes.
there, Alex.
Yes.
So you know what? We're going to give you a breather here for a moment, and we're going to bring up some stuff you'll be doing at the end of the year, and we'll do that right after this.
Great.
Oh goodness, go faster, those electrons are flying, oh my goodness!
Based on laying a foundation of what is electricity and how we use electricity in our lives, I want the students to have ownership and to understand that electricity is a big part of their life. What a great way to teach that you are a conductor. We talked about circuits when they made that circle and connected.
You're going to use your fingertips as if it's a plug, and you're going to touch the two metal strips.
The teacher actually presented one way of developing a circuit, and then the kids explored all kinds of different ways of replicating that circuit, but also being creative and creating their own circuit. It really helps with understanding, and that they'll be able to transfer that knowledge to other forms of electricity.
Radio. A blender.
Very nice. It cooks our food, doesn't it? Teachers are telling me that they love the thoroughness of the lessons, the planning and organization of the lessons, that the students are engaged, they know their children are learning. We've become so focused on, is it A, B, C, or D? Just read and answer, and we forget that we need to play. We need to exchange ideas, we need to talk, we need to justify our thinking, and so this is important.
We were very fortunate in that Chevron actually funded this project. We needed the funds to purchase the equipment, to actually buy the time of our excellent teacher, and to be able to develop lessons so that we would be able to come into a school, demonstrate a lesson, leave the materials with the classroom teacher, and then have them conduct the next 4 lessons. Because it's important for this not to be just a demonstration. This needs to be a learning experience for the teachers so that they can continue the teaching of science.
And just a reminder, we do have phone tutors available until 5:30. That phone number is 636-4357. At the bottom of your screen, you can also see the toll-free number, 1-866-636-6284. In studio with us right now, we have a Hart Hawk, Alex, who is in 5th grade. How long have you been at Hart?
Well, I was in kindergarten for Austria, so since 1st grade.
Okay, so you began school in Austria.
Yes.
And then you came to the United States, and you've been at Hart since 1st grade.
Yes.
And now you're going to Vermont for 6th
Yes.
grade. So you're going to be a well-traveled young man in just a matter of a couple of years right
We've
there.
moved twice in California, actually.
Where was the other place in California? Was it close to where you're at
yes,
now? Oh, okay.
it was
So
like a
you still
rented
stayed a
house.
California boy
Yeah.
for those couple of years. You know, I still consider myself a New Yorker, even though I think I'm getting close to, I've been out here for a while. Anyway, Alex, now what we're going to do is we're going to work on volume right now, okay? And in your book, this is the problem that you guys are going to be working on soon, where you have to find the volume. And we can see that that figure has dimensions of 2 by 4 by 5. And down below it's got the V because they want you to find the volume of that. So I'd like you to go over to the board and you guys are going to work together. But before you start multiplying things that you think you need to, we're going to talk a little bit about volume, what it means, and how we get to that point. Okay?
Okay, so they want you to find volume. So do you know what volume means?
Yes, like it's the height multiplied by the length multiplied by...
Well, that's how you get it, but do you know what volume is?
It's pretty much the center and outside of an object.
Yeah, so if I was going to fill this with water or sand or sugar or
that
something.
would be the volume.
Right, the volume is how much is going to hold, right? How much water or how much whatever we're going to put in there. Peanut butter maybe, right? So what we want to do is, you're talking about multiplying, and so if we think about how much space is inside that box, we're going to start by think about one layer. We've got 2 feet across and we've got 4 feet back. So if we did one layer right here, and we're just going to think of filling this thing up with cubes, right? We know that area, if I had the bottom of this was 2 feet by 4 feet, right? I know that the area
would be
2 times 4, wouldn't it?
8 feet.
So the area is going to be 8 square feet, right? And what that is how many of those squares it takes to cover this, doesn't it? Right?
8 squares.
So we would take 8 squares to cover the bottom of that. Now for each one of those squares, what we're going to do is we're going to put a little cube in there. And so what we're going to do is we're going to make one layer of cubes. Now we've got to go 3 dimensions, right? So instead of just area, we've got volume now, and that's the space in there. And so we know that if we put one layer of cubes, it's going to take 8 of those cubes, right? 8 cubes for one, that'll cover one layer. But how many layers are we going to have? How high is this thing?
This is 5 feet high.
It's 5 feet, so we're going to have 5 layers of cubes, right?
So it's
we're going to take
5 times 8.
So it's going to be 5 times 8. So if you take 5 times 8,
it's 40.
And so just like you said, you found the number of cubes, and notice this was square feet for the area, and volume is going to be in little cubes, and so that's cubic, or raised to the 3rd power. That's going to be in cubic feet for the volume, and that's the 3-dimensional space that's inside the box. But like you said, there's a nice formula, because what you just did was you multiplied 2 times 4 to get 8, 8 times 5 to get 40. So if you just take length, if you just take, there's your volume.
The length times
the length times the width times
the height.
And that's going to give you the volume of that box. There you go.
There you go. And I think he's going to put the feet and then, good, with the
so we
cube
got
up there.
Cubic feet for volume, right?
All right, nicely done. So I need you to erase the board, and then you can go ahead and start working on your artistry, Chuck, while we're going to take a look at this problem, Alex. It's going to be a little different now. All right, we're once again going to find the volume, but the figure is not as nice as...
Okay.
So we've got a composite figure now, all right?
So it's a rectangle, but then comes out like this.
Right, so we'll leave that up there for you a moment so that you can
and
go
then
ahead
we're going
and
to make this 3-dimensional.
copy that down. So Alex, while Chuck is putting that on the board, is there anything that you are anticipating about Vermont? Anything you're looking forward to, maybe?
7 in back. And 6 on this side.
Well, yeah, hundreds of things. School seems really nice.
Okay, so have you been there?
3.
No,
Okay.
only like in Skype chats.
Oh, okay, so so you're getting familiar with it. And the reason I like that you're doing the Skype chat, because what we're going to do probably next year is maybe do a Skype call with you on air. Sound good?
Yeah.
All right, so it would be 7 o'clock your time. All right, so you probably maybe get close to getting finished with dinner maybe, and maybe some homework, and then we'll go ahead and what we'd like to do is maybe do it during the winter time possibly, so you have some snow out there. Have you gone snow skiing yet?
Well, I can ski, but I usually take my anticipations into Shaun White skateboard.
Oh, okay. Well, there you go. So you're doing some different activities.
Yes.
Well, snow skiing is going to be kind of a big thing if you're going to be in Vermont for any period of time. So I think Chuck has got that up on the board.
Okay.
So it's time for you to get back to work.
All right, so they want you to find the volume, right? The volume of this box, and it's not just rectangular. So what we have to do, just like we did with the other box, we're going to find how much one layer is, and it turns out that this is just one layer. So if we can find the area right here of the bottom, right? So let's go, I'm going to draw this over here. Let me draw this over here. So here's looking down on this. It's 7 across, and then this is going to be 6, and then it comes in like this, and this is 3, and this is 2, okay, and 6 by 7.
What's
so what
the
we
1
want to do is,
centimeter for?
that's how thick it is. So we're going to find just the area of this top part, okay?
Got it.
Just like we found the area on the bottom. So let's find this area, okay? And to find the area, well, we
have
don't
to
really have a
multiply.
formula. We don't really have a formula for this funny shape. So what we're going to do is we're going to break this up into 2 rectangles. Can you find the area of this rectangle right here? Well, what are the dimensions?
42.
Yeah, it's 7 by 6, isn't it?
7 times.
So it's going to be 42. So let's go ahead and put that in. That's going to be 42 inside. And can you find the area of this little rectangle? That's going to be 6. So the total area, let's put that over here. The total area of this is going to be 42 plus 6. So what's the total area of that? What's 42 plus 6?
48.
48. So write that down. 48. So the area of the top and the bottom of this is going to be 48. Let's see, we're in centimeters, weren't we? Centimeters squared. Now what Mr. Kushon wants us to do is make this 3-dimensional. So if we were going to fill this up and make it 3-dimensional, we're going to take, for every one of these little squares right here, we're going to put a cube there. And very nicely for the problem you gave him, Mike, is that it's only 1 centimeter thick, right? So if you're going to do the area, right, 48, times how thick it is, it's just going to be 48 times 1, which is? Yeah, it's a tough one, huh? And the area was 48 square centimeters, but the volume is going to be 48 centimeters
3.
to the 3rd power cubed, because we're doing little cubes to cover that up. All right? So he gave us a nice one with that 1 for
Right.
the thickness.
But I wanted you guys to do that because with that kind of strange looking figure, some kids would get intimidated with it possibly, but you're still doing the same process as the one before.
And and the rectangles were so easy to figure out here separately, and then just add them together.
Right. All right. Clear that one off, and we've got one final one for you guys to work on.
Right there.
All right. A little different type of problem.
Okay?
All right. Leo wants to paint a mural that covers a wall. The wall is 1,440 square feet.
1,440 square feet.
Right. That's the area of the wall.
Okay?
The height is 2/5 the length.
Okay.
We need to find the height and the length.
Okay, so if the height is less, so here's the wall. Let me draw it right here. And you know that the area is 1,440 square feet?
Yes.
And we don't know the length of the height. We just know that one's.
2/5 of.
So if I
So
know
the height
that-
is 2/5
If I
the
know
length.
that this is the length, then the height, h, is 2/5 of that.
So Alex, get up there. You're going to help work on this one. That's
Okay.
all we've got.
So that's all. So now, do we want to do this by the table, or do we want to try and solve an equation?
Well, Alex, you're the one up there going to have to work on this. Would you like to do a table or an equation?
Equation.
Okay. So if we're going to use an equation, instead of L, let's call this X, huh? So how do you find the area of that wall? How do you find the area? It's going to be the length times the height, isn't it?
Yes.
Okay?
So
Well,
do we divide the 14?
Let's just go ahead, right? So we know that base times height, right, is going to be the area. And we said the base is the length, so let's call that
L.
x.
Oh, X.
Okay, and then we're going to multiply that, and that's going to be 2/5 of x, isn't it? 2/5 x. So we're going to multiply 2/5 times x. Okay? So that's the area. But well, let's see, we just said, he told us the area was 1,440.
Zero.
Okay, so let's see if we can figure this out. We want to write this equation. Let's see, what's x times 2/5 x? Well, do you know what x times x is?
X squared.
X squared. So this is going to be, write that down, x squared times 2/5. Yeah, let's see, I think we need to change the color on that because let's go back to a darker color. I don't think that yellow is showing up. So how about a blue? There you go. Okay, so let's write, there you go. So let's write x squared and then times 2/5, okay? And then 2/5. So we want 2/5 times x squared to be 1,440. Now, do you know how to solve an equation like this, and how do you get rid of that 2/5? You know how to undo multiplying by 2/5? Well, you remember we talked about reciprocals? So what we can do is we can multiply that by, no, multiply it right here. Multiply it times 5/2 over there. So multiply that side by the reciprocal. So right here, times 5/2, right? Because this is an equation, we'll do the same thing over here and multiply this side by 5/2. Right? So what's 2/5 times 5/2?
10 over 10,
Which
which will
is?
equal a whole.
1. So
Yeah.
these reduce, don't they? Right? The 2's make a 1 and the 5's make a 1. So what we get is, now we're back to fractions, okay? X squared is going to equal 5/2 times 1,440.
And for the sake of time, that will be 3,600.
Right? Now we make that now he's done the work for us. That's going to be 3,600, you said?
Correct.
Okay. So here's the question. What number squared is equal to 3,600? Can you give me a number when you multiply times itself, you get 3,000, you get 3,600?
Ooh, 600.
Well, close.
60.
60, because 60 times 60 is 6
And you've
times
got
6.
1 minute left.
And it looks like x is 60. Well, now, what was the question in this
We
problem?
need the length and the height.
So if we go back to this problem, we said x is going to be the length. So this is going to be 60. And what's 2/5 of 60? And let's see. 5 goes into 60 12 times. It looks like that's going to be 24.
24 over 1. Just
24.
take away the 24 and you got,
So it looks like 24 by 60. Mike, it looks like that's the size of the ball.
And indeed, that is correct. Nicely done. Alex,
Good
come on
problem.
over here.
A lot of stuff to do.
Right, so that was a great problem right there. So you've come on over.
on.
You've done some multiplying of mixed numbers fractions. You've divided fractions. You've worked on volume. You've worked on volume with a composite figure. And now you've done that word problem where you had to do a lot. I think you got your work in today. You feel good? All right. You know what? You are our newest East Coast ambassador. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District. with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.